first lowest guy. So if I win, what do I expect the next person to be bidding? So I'm trying to just beat him, right? Pretty intuitive. And this is exactly the right formula if we have perfectly inelastic demand. If there's elastic demand, that's going to give me a further reason to reduce my prices a bit because I can increase the demand by reducing them. But I'm going to basically ignore that. So let's just focus on the case where I'm just trying to beat the next guy. So in this case, what happens is Victor Liu? No. No turnout today. Does anyone want to explain what happens when the number of firms gets large in this type of a situation? Edward, yeah.
Like the cost of you being the last guy is going to increase because there's more people bidding.
Yeah, so you can that's right. So basically, there's going to be more people who are close to the lowest cost, and they're going to be getting, and the next lowest person is going to be closer and closer to you. So everything is going to be driven down to that minimum cost, right? And so my expectation of the next highest guy converges to what I have, right? Because there's so many people competing, breathing down my neck. And the highest guy converges to the lowest cost. And thus price converges to the lowest constant marginal cost. Intuitively, the idea here is that as the number of firms increases, each individual firm becomes less necessary, right? What was allowing me to charge a price that was above my cost was the fact that I was sort of the only one who could be supplying the market. But when there's lots of people, I'm less necessary, and therefore I am forced to bid closer to my cost to be able to win the competition. So again here, as the number of firms increases, and you can sort of do an analysis of how quickly this goes towards the bottom cost, but it's also sort of like an exponential die-up. So again, we get a pretty similar conclusion to what we get in the corner. Okay, so again, in different settings, we obtain sort of another version of Cournot's theorem. So as the firms increase, prices gradually converge to the lowest constant marginal cost. Now, if all costs were not constant marginal, then everyone would be selling different quantities, but the quantities that they were selling would become efficient as the number of firms increased as well. So what this shows is that even with a very different model, we obtain the same basic result. And in fact, there's a lot of models you can show that all have this same basic flavor. So we can sort of take this as a general rule about competition. Yeah, Edward?
Oh, I just want to clarify.
Yeah.
So when you say the lowest marginal cost, is the firm that can make the most markup, or make the most big profit, that is going to win because it has the lowest marginal cost compared to everybody else.
Yeah, if a firm has lower marginal cost than everybody else, it's going to want to bid lower because it's able to make more profits by winning, right?
Yeah, I just want to...
And can win at a lower price, right, and still make profits. So what this says is the general rule about competition that comes out of Cournot's theorem is eventually, but not immediately, competition drives prices to cost. With enough firms, price should be close to efficient. And then the question becomes, well, what do we mean by enough firms? So Bresnahan and Race 1991 proposed a very clever way to study this. So they noticed that as a market grows larger, it can support more firms. So if you think about like a really small town versus a somewhat small town, it's very likely there's going to be more dentists, more mechanics, etc. in the somewhat bigger than in the somewhat smaller town, right? And in particular, let's call the number of people living in the town n, and let's say that let's say that in order for a town to support n firms, it needs to have Sn people. So if the lowest population at which we get 2 dentists is 1,000 people, S sub 2 would be 1,000. If the lowest population at which we get 7 dentists is 5,000, then S sub 7 would be 5,000, right? And then we can say S sub n, little s sub n over n is sort of a measure of how many clients are necessary for a firm when the number of firms is equal to n, right? So if 5,000 over 7 was, whatever it is, you can do the calculation, then that would say that that's how many clients you need in order, in an industry with 7 people, to pay your fixed costs, right? Okay, so imagine that prices stayed constant as the number of firms increased, right? And that all firms had the same fixed cost, right? Well then, this number should just be completely constant, right? Because as the number of people increases, the number per firm that you need if the price is constant in order to defray your fixed cost should be constant, right? On the other hand, imagine that prices fall as the number of firms increases, right? Then it should take more people to support 2 firms, more people per firm to support 2 firms than it takes to support 1 firm. Because if the prices are lower with 2 firms, the firms can only defray their fixed costs if there's a larger number of clients, right? So that is, we should see S sub 3 being less than S sub 2 being less than S sub 1. Now there's other reasons why you could get a pattern like this. For example, if firms had different fixed costs of entry, and the firms with the lowest fixed cost entered first, and the with higher fixed costs entered later, this also might occur. Sorry. This should be exactly the opposite. Yeah, S sub 3 should be greater than S sub 1, it should be greater than S sub 2, right? Sorry. Okay, so the nice thing about this strategy is that this is a really easy thing to implement. As long as you can get some basic data, you can just go and look at a bunch of small towns, look at a bunch of industries, and see what these numbers look like, right? And so what they did is they found 5 professions in a large sample of rural towns in the United States, and they found how many people lived in each of these towns and how many professionals there were. And when does S start to sort of level off? And they viewed this as convergence towards competitive equilibrium. So here's what they did. They did how many people are necessary per firm are necessary to support it when there's 5 firms, divided by how many people are necessary to support with n firms, right? And that should be high if n is small, right? Because then S will be small, and then it should level out as we get towards perfect competition. And once it's fully leveled out, that should basically indicate that we're at a competitive environment, right? Because basically, in other words, increasing the number of firms is not going to further reduce the prices. And here's what you see. So this is druggists. These are tire dealers, doctors, dentists, and plumbers. And the pattern you pretty clearly see is there's a big drop from 3 to 2. There's a fairly big drop from 2 to 3. And then there's very little going on. So most of competition seems to come with the first few firms. So the die-off seems to be relatively quick in the number of firms. So, so far, what we've been doing is assuming that the goods were homogeneous, including in this little empirical exercise. But if you think about it, most competition in the real world happens between firms that are not selling exactly the same product, right? The merger doesn't really eliminate products in most cases. When AT&T merges with T-Mobile, it's not like they're going to completely eliminate one of the services. It really just consolidates the ownership. Or when PepsiCo, merges different fast food companies, KFC and McDonald's continue to exist, right? So, a natural question is whether in these cases it's also true that competition helps or a merger hinders competition. Reduction in prices. So the simplest case is just to focus on two firms that are merging with one another. And the reason to do that, even though all these firms are obviously competing with other firms, is that it's sort of like the monopoly model. It lets us focus on like the key thing that's going on without getting distracted by things that are not core to what we're interested in analyzing. So we'll add other firms later. And let's start by assuming Nash prices, because that's what we talked about most last lecture. So each firm, I, has a demand that depends on its price and the price of its competitor. And it earns profits, which are its price times its quantity, minus its cost, which also depends on its quantity, right? And let's denote the partial derivatives with respect to the first and second arguments as q sub 1 and q sub 2. Okay? Okay, so what's the first order condition here? Well, let's take the derivative of profits with respect to price. What do we get? Well, by the product rule, we get qi by taking the derivative of p, plus qi sub 1 times pi, minus c sub I times q sub 1, right? And that's all equal to 0. And then if we let c sub I prime, ci prime equal m marginal cost of firm I, right? And divide by qi sub 1, we get this sort of classic equation which says that price is equal to marginal cost plus the markup, right? This is what we've been doing over and over again. Price equals marginal cost plus the Cournot distortion. Now let's imagine that both of the two firms merge with one another. Now their joint profits are going to be P1 Q1 P plus P2 Q2 minus the two costs. Jeez. Okay, sorry about that. And then we take the derivative of that, and using the exact same reasoning, we get that the derivative with respect to price 1 is Q1 plus the markup on good 1 times Q1 sub 1 plus the markup on good 2 times Q2 sub 2. And that's equal to 0. Okay. So now let's divide through by Q1 sub 1, and we get price equals marginal cost plus the Cournot distortion that we talked about, plus this new term up here. And this is going to be the key thing we're interested in. This is the new incentive created by the merger between the firms. So the first two terms are exactly the same as before, and the third term, which is the effect of the merger, is what we want to focus on. Okay. So this quantity is going to be called the upward pricing pressure, or UPP, from good 2 to good 1. And what is it? It's the price of good 2 minus the cost, marginal cost of good 2, times the ratio of the derivative of the second quantity with respect to the first firm's price, and over the negative of the derivative of the first firm's quantity with respect to its own price. Okay, so this first term is called the markup, right? That's the markup on the partner's product. And the second term is called the diversion ratio from good 1 to good 2. So as long as the two goods are substitutes, as long as my increasing my price increases the quantity sold by my rival, this is going to be positive, and so this whole thing is going to be positive, right? Because this is negative and there's a negative sign there. And the right way to interpret this is, imagine that Burger King sells a burger, right, to somebody. That person now doesn't need to go buy a burger, right? Now there's a chance that had they not been satisfied by the Burger King burger, they would have gone and bought a burger at McDonald's, right? That chance is the sort of harm that Burger King does to McDonald's by selling that burger, right? So the idea is, you know, every time Burger King sells a burger, how many sales does McDonald's lose? And why does this reflect this? Well, this says, if I increase my price, how many sales of my rival does that cause?